today we will be talking about Chapter 5, back to building ML pipelines. We're talking about data preprocessing. And this is perhaps a chapter that's worth you to spend more time on your own, as you know, as we all know, data scientists or engineers spend lots of time on processing the data, cleaning the data, and this is where we do this basically, with TFT, TensorFlow transform under the TFX component, and this is where a lot of these TensorFlow functions, not necessarily under TFX, but like even a lot of TensorFlow functions from the main library could come in as well to help you process the data. And so your knowledge about TensorFlow would be very useful here. So, okay, so I want to get started with reading first. Then we can talk about the chapter, obviously. So let's spend 45 minutes on the reading. Okay, this is a relatively shorter chapter, but I think it is a very important chapter before we jump into model training and model analysis, and of course the Scikit-Learn workshop as well. So great. So let's Mash, if you don't mind setting up the timer, let's give it
on it.
45 minutes till 7:30 p.m. PST or 10:30 p.m. EST. That'd be great. Okay. Talk to you guys in 45 minutes.
folks. Just 20 more seconds. Wen Chen, do you want to take over?
Yeah. Okay. Sounds great. Thank you, Mash. All right. I'm seeing some comments in the chat. Some sort of, okay. I think Nidhi was talking about some graph, and Mayank responded. Cool. All right. So let me focus on, so today's agenda is basically go through the book, obviously, but also as we discussed last time, we want to try to incorporate Google TensorFlow TFX's own tutorial into the class as well, because they provide really good tutorial. I think some of the book materials do provide insights, but it doesn't have kind of the end-to-end pipeline until the later chapters. So I think, but I think it's good to keep that in mind in terms of that end-to-end pipeline, even, you know, as we go along through each of these chapters. So let me start sharing my screen. Okay, so today we're talking about data preprocessing, right? So it is the sort of the third step, okay? After we ingest the data, validate the data, then we want to pre-process the data. And after that, we're just going to train the data. And obviously we need to evaluate and analyze our model. Then we push it for deployment. Then in the end, basically, we use orchestration tools such as Kubeflow pipelines and Airflow or Apache Beam to orchestrate the pipelines. Okay, so without further delay, let's get into this chapter. And this chapter is important because this is where a lot of the mistakes can happen, okay? And one of the biggest mistakes is misalignment between training and serving. And that's what this chart is really is. Basically, you know, currently most of the data scientists would use Pandas or Spark for training, but a lot of these, when it's in production, that pre-processing step obviously, you know, doesn't happen on your local laptop, and it needs to happen in some sort of API environment. And sometimes you could have basically misalignments in terms of pre-processing steps. And we'll talk more about that when we get to Scikit-Learn as well, because then you don't have TFX or TensorFlow transform. So, I mean, obviously there are ways to mitigate this with Scikit-Learn as well. So, yeah, but that is where things could happen. And TensorFlow transform sort of helps you with that, because, you know, everything kind of just stay within one, within the graph, the TensorFlow graph that's generated from TensorFlow transform. So you would be able to avoid the misalignment of the pre-processing steps. Okay, and this is a big topic. Obviously, I feel like train serve skill could deserve its own book, to be honest, as a very general problem that exists currently within the industry right now, and it's not just pre-processing steps, right? It could be, your distribution in your serving or production environments, data distribution is changing because things changed. For example, COVID, we talked about that. Then it's not something that you could just prevent, but your model will just get screwed up pretty much because your model was never trained on that environment condition at all. Hasn't happened before, or I mean, historically, obviously, we've had pandemic, but a scale like COVID-19, has not happened for a long time. So, and there could be many other reasons that we could have train serve skill. So just be aware that it is a very big topic. So beyond pre-processing steps. So, okay. And TFT uses Apache Beam again under the hood to execute pre-processing instructions. This allows us to distribute the pre-processing if needed on the Apache Beam backend of our choice. So if you don't have access to Google Cloud's data flow product or Apache Spark or Apache Flink cluster, Apache Beam will default back to its direct runner mode. Okay, so any questions on this?
Yeah, I'm not familiar with the direct runner mode, whatever that is.
What does Apache backend mean? Apache Beam backend mean?
Yeah, I think what this means is basically TFT is built on top of Apache Beam. I'm not 100%. I'm not very familiar with Apache Beam either, unfortunately. But it is a library under Apache and helps you to parallelly process certain steps. Let me just Google really quick. Apache Beam TFX. So Apache Beam provides a framework for running batch and streaming data processing jobs that run a variety of execution engines. Several of the TFX libraries use Beam for running tasks, which enables a high degree of scalability across compute clusters. Beam includes support for a variety of execution engines or runners, including a direct runner, which runs on a single compute node and is very useful for deployment, testing, or small deployments. So I guess that's what it is, Joseph. That's what direct runner is.
Right, so you can just run it on your own machine, on your own laptop.
Yeah, that's pretty much what it is. But I guess, if you do want to scale it up, then, that's where Spark, Flink can come in to help. I would suspect that would require additional configuration and stuff. For Google Cloud users, Dataflow is the recommended runner, which provides a serverless and cost-effective platform through auto-scaling of resources. dynamic work rebalancing, deep integration with other Google Cloud services. So let's look into data flow. Okay, so data flow is unified stream and batch data processing that's serverless, fast, and cost effective. So basically, instead of running these data processing tasks on your laptop or on your server, you hand that to data flow. And it's fully managed data processing service, automated provisioning and management of processing resources, horizontal auto-scaling of worker resources to maximize resource utilization, streaming data analytics with speed, simplify operations and management, reduce total cost of ownership. So basically, when you need to handle lots of data, and you don't want to build all these Apache Beam, Apache Flink, and Spark on your own, just use data flow. That's basically what it means. So that you're not managing the data processing pipelines yourself. Okay, you just hand it to data flow. That's it. Okay, I'm sure there's equivalent tool for AWS. Let me do a quick search. AWS processing tools. Serverless data processing. Okay. So someone had chat. Apache Beam. Okay.
Isn't it just Data Wrangler on AWS?
I've never used AWS Data Wrangler. Is that under SageMaker?
That's the one.
Okay, so seems like we have that, but obviously I don't know if this will be compatible with, I don't think this will be compatible with TFX, obviously.
Yeah, these are all specific frameworks. Data flow at Google is different and was set up to support the trifecta data prep product on Google Cloud. Things AWS did it their own way.
Here's a result from Google.
That's your Siri.
My Google Android.
Yeah. So, sorry, did you finish, Mesh?
That was the point.
Okay. So if you don't want to use SageMaker Data Wrangler, obviously you could use, something like Lambda, but again, this is on AWS and I would suspect that this would have to be customized on your end, and it wouldn't be as easy as the integration with Dataflow with TFX, because Dataflow is Google's product. But again, AWS Lambda is I've used it before. It's framework agnostic. It's pretty much just if you have Python, and it supports probably other languages as well. So you can put simple functions on AWS Lambda, and also now it has container support, so you can put your container. You could probably containerize your pipeline processing pipeline in a container and just serve that on AWS Lambda. That could also be a very an alternative to that. And it seems like you could even connect Kinesis with Lambda. I'm actually learning Kinesis right now for streaming data. But it seems like if you could connect these two together, then you could even handle stream data processing with these two tools together, which is pretty cool. Okay, and obviously on Google's ends, we're talking about BigQuery for data ingestion, data flow for data processing, and Google's own model platform and Google Cloud Storage for model storage. So, and on AWS's ends, I guess, you could connect that with any of the database choices, Dynamo, RDS, Athena, and things like that. So, okay.
Since you're doing that overview, just also remember on Microsoft Azure, this is where you would use Azure Functions. And Azure Functions are also very, very deep, ties to stream analytics and so on. Yeah.
Azure Functions.
Yeah,
cool.
It's all their serverless. And Wencheng, you and I talked about this for these things are useful when you're dealing with big data and streaming big data.
Yeah, absolutely. So, and a lot of times, it's just good to have these fully managed services, if you have the means to pay for it. But obviously, you can choose to build a lot of these tools yourselves with open source Apache tools as well. I haven't used Azure Functions before, but is Azure? I guess Azure is probably has the smallest market share, right, Nash?
I would say the other way around, because almost every company has Azure. Microsoft Azure has a dominant footprint because they're pretty much everywhere. It's AWS, without going into that whole discussion about who wins or anything, but Azure is certainly widely available. It just, at this point, these are largely around what is your specific use case, what are your constraints, including your technology stack constraints, what is your budget. The pricing for these things are all going to vary wildly. And then when you negotiate the variable pricing and so on, then the calculations completely change there as well.
Yeah. And so you're saying after AWS, obviously AWS number one. So you're saying after AWS, now it's Azure number two.
That's one way to look at it.
Yeah.
Yeah.
Oh wow, I didn't know that. Okay, so Google is falling behind on that, on cloud computing.
I wouldn't say fallen behind. It's trying to catch up.
I mean, among the top three.
Yeah.
Yeah. Okay. Cool.
And
cool.
then when global, our friends in India have equal access to Baidu and the other clouds as well. So
yeah, Alibaba Cloud, Huawei and stuff.
Yeah, Alibaba's and Baidu's. Yeah. And so those, I don't even know what theirs look like. I believe Baidu forks pretty much a lot of what Azure does. So that should look a little similar.
Mm-hmm. Cool. Thank you.
Also, just to add, another advantage with the Azure products is you actually have the ability to deploy a lot of that on-prem as well. So you can have kind of a hybrid cloud type approach as well. So that's helpful. Whereas with the AWS products, it's all cloud-based.
It's all cloud. Mm-hmm.
Mm.
Microsoft Azure is big into hybrid. They recognize that is a distinct differentiator for them.
Why do we what's the advantage of using
security
And
Right.
legacy and
Yeah,
legacy.
and legacy. Yep, that's another one
and
too.
legacy?
Yeah.
Interesting. Cool. Yeah, AWS is all on clouds. I've just been digging deeper and deeper into all kinds of AWS tools. Yeah, and I have to say, it has not been a very easy process either. And I've heard AWS is probably the easiest one. Yeah. Okay. Yeah, in it's a lot of security configuration and row configurations, IAM management, rows, permissions as well, and yeah. So when we get to deployment, I'll be talking more on AWS for sure. I'm not as familiar on other platforms. But I've certainly talk more on AWS with my knowledge. So, okay. Back to the book. Okay. Deploying preprocessing steps and ML model as one artifact to, yes. So we talked about this. To avoid a misalignment between the preprocessing steps and the trained model, the exported model of our pipeline should include the preprocessing graph in the trained model. So basically, your pipeline would include the preprocessing steps as a graph, and then you can deploy the model like any other TensorFlow model. But during our inference, the data will be pre-processed on the model server as part of the model inference. This avoids the requirement that preprocessing happen on the client side and simplifies the development of clients that request the model predictions. Okay, so this is actually, very less talked about in majority of data science education. Unfortunately, we always get to just training your model and get to the validation and predict something, and that's it. But in inference, when you're inferring your data in production environments, there needs to be pre-processing steps that match your training environment on the fly, and and seems like this takes care of that quite nicely. So very helpful. All right. Checking your pre-processing results in your pipeline, difference between tf.data and tf.transform. I think this is all pretty straightforward stuff. Any questions on this before we jump into the pre-processing steps?
Just generally, do you have to use tf.transform? Like if you have an image pipeline and you've written pre-processing that's in OpenCV, do you have to kind of reconvert everything to be using these specific tf.transform steps?
Yeah, so I think that's pretty much what it is. It has to, at least it has to stay within the TensorFlow ecosystem. Otherwise, it wouldn't work. I think the book mentioned it somewhere. Data pre-processing with TF. Yes, so all transformation applied to the tensors have to be TensorFlow operations. This allows TFT to effectively distribute the pre-processing steps.
And also, when saying if you go back to the website,
Which website?
The page for Apache Beam, we just read just now.
Apache Beam?
Yes,
one?
this one. Yes,
Okay.
yes, this one. So if you scroll down a bit, custom Python code and dependencies, it says something about talks about problems when you have custom Python code, which is different from TFX. Yeah, this one of the part.
Okay, one notable complexity of using Beam in the TFX pipeline is handling custom code or the dependencies needed from additional Python modules. Here are some examples of when this might be an issue. Pre-processing function needs to refer to the user's own Python module, a custom extractor for the evaluated components, custom modules which are subclass for. TFX relies on the Beam's support for managing Python pipeline dependencies to handle Python dependencies. Currently, there are two ways to manage this. Providing Python code and dependencies as source package. Data flow only using a container image as worker. Okay, so maybe, I don't know how this could be done. Python, maybe that's managing Python pipeline dependencies. I mean, does that allow you to go out of TensorFlow ecosystem in terms of pre-processing code? Does anyone know?
That needs to be checked, I guess. Probably. Yeah.
Sorry, say that again?
Someone needs to check and find out how things work on that. I mean, using
Yeah.
OpenCV within this and then see how things work out.
Yeah, I think I mean, obviously you could always write a lot of customization code, but I think directly, at least from the bookends, that's what I refer to. Basically, all transformations applied to Tensor have to be TensorFlow operations. Maybe there's a way to convert other operations. I don't know. Good question. So,
Just seems a bit like you build in a walled garden if you can only use the features that they have, and if they run out of features, then you might get stuck.
yeah, and then
No, but I have a viewpoint on this. If you look at it from a TensorFlow perspective and you go down the backend with respect to the how this transformation will occur. So uh, if it's in the same kind of an ecosystem or the walled garden as you just alluded to, with respect to the transformations and the operations, the low level operations that we apply, like the uh, ops, uh, uh, the operations with respect to the compilers and the intermediate representations that you put in, that will be a lot faster inside end-to-end baked pipeline, which is on the same platform, uh, as opposed to you firstly transform or do some operations in one part of uh, 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 platform and then transfer it to some other platform. Then you will have to do some additional steps to convert into that data type, and then do that low level operations, then revert it to TensorFlow transform and the TFX platform. So that's if you have everything on one, it will be easier to have a distributional effect in which you can easily scale up. And with the TF records and the other optimization that the TensorFlow ecosystem has built in. That's the one of the reasons why this is the industry's leading source on mm, your scalability in a large distributed environment. That's my 2 cents on this whole discussion. Thanks.
Okay. Okay, and this is not even TFT, right? So we're just talking about custom Python code in the TFX pipeline. So this is not necessarily telling us that we're able to use custom Python code for transformation. So it might, but doesn't seem like it is. But there, but at least on Apache Beam wise. So this is telling us, hey, basically we could use our own package, right? So develop your own source package. And this is what it is, right? So we've been doing that, right? And that's what setup.py is for. When you have that, you're basically developing your own source package, and you can import your package as consumer complaint. And that's what this is for. But obviously, that's not what this is. And basically, if you wanted something to be customized and used in TFX pipeline, you would have to package it and import it as your own package. So it could be like import consumer complaints and call your own package, and then incorporate your codes into the pipeline. And that's what this means, basically. Okay, but again, I don't know if this applies to TFT or any pre-processing steps.
Okay, thanks.
Yeah. But, yes, OpenCV is, I guess that's what it is, I think TensorFlow probably covers a lot of these, image processing tasks. But again, there are many other libraries that are really great, such as OpenCV. Yeah, it will be a little tough, I guess, when it comes to incorporating these things into the TFX pipeline. So, all right. So let's talk about this a little more. We want to basically ingest raw data and raw data schema and pass into the pre-processing FN and transform graph and transform data. So that's what TensorFlow transform does for us. And one thing to stress on this is this function is a function that you can't really change its name. It has to be named as pre-processing _fn, and it has to and it will need to be passed in to your components as a module file. So this is the parameter to pass in for your pre-processing codes in the module file. And in that module file, you would need to have that pre-processing FN laid out right here. And TensorFlow transform components will be able to detect this function and call this function as a callback function for pre-processing inputs. Okay, and these are the pre-processing steps that the book talks about. And you can locate this file in, let me see. This is the book repository. You can locate this file in components folder, okay? That's where it is in the book's GitHub, okay, as a reference. And these are the codes that the book talked about in this chapter. Okay, I basically just moved it over to the practice example folder that I have for the practice repo. I already committed this code to the GitHub. So cool. So when we execute the transform component, the preprocessing FN function will receive the raw data, apply the transformation, and return the processed data. The data is provided as TensorFlow tensors or sparse tensors. All transformations, again, applied to the tensors will have to be TensorFlow operations. This allows TFT to effectively distribute the preprocessing steps. TFT functions that perform elaborated pre-processing steps behind the scenes, like tft.compute and apply vocabulary, can be spotted by the prefix TFT. It is common practice to map TFT to the abbreviation TFT in the Python namespace. Normal TensorFlow operations will be loaded with the common prefix TF, as in tf-reshape. And there are other functions or useful functions within the TFT module. And you can also pip install TFT by itself, okay? And the way how we're gonna process our own specific data sets in the context of this book is basically these steps, okay? We're gonna transform the name of the feature with XF. So basically, we'll have columns that have the feature names and underscore XF. And also, we want to fill in the replace missing values in a sparse tensor, and basically then do a tf.squeeze operation. Tf.squeeze basically takes out the dimension of 1 on axis equals to 1. So basically second dimension, if it's 1, we'll remove that dimension. Okay, and this is basically converting sparse tensor to dense tensor. And we also have a convert num to 1 hot, converting a label 0 or 1 into a 1 hot vector with tf.1 hot. So this is where tf function and this tf function as well. So those are not TFT functions. Those are just general TF functions. And doing the reshape right here. Also, we want to convert the zip codes because a lot of these zip codes only have 3 digits or 2 digits actually, and the last 3 digits are XXX. So we want to convert that to 000. And the book was saying basically, for that column or feature, it doesn't make sense to 1 hot encode that. So bucketization is the way to go on this particular feature. And basically right now, for this function, we're just replacing the last 3 digits or XXX with 000. So that's a regex tf.string operation, regex replace zip codes. So I guess that's X. That's a regex pattern, replacing X with zeros. And then convert that to numbers. And out type is tf.flow32. So maybe it was returns, why does it say integer 64 here? Okay, maybe there's yeah, I don't know why the comment or docstring says integer 64, but the out type is tf.float 32 and tf.float 32 as well here. Okay, maybe there's a mistake here. And then every one of these helper function flows into this pre-processing FN, right? So when you do your own project, what it means is that you want to define all your other pre-processing functions, you know, elsewhere outside of this pre-processing FN, and just let every single function flows into a main logic called pre-processing FN, and then just return the outputs so that the transformer component within the TFX pipeline will be able to call this as a callback function. Okay, and then we'll transform the data. So for in the book define or categorize these features into three categories. One is one-hot features, one is bucket features, one is text features. Okay, so under one-hot features, we have product, subproduct, company response, state, issue, and these are the features that basically says, hey, those are one-hot features. We want to just one-hot encoding them. And feature dimensionality, I suspect that's the unique types or categories. I'm not too sure. I'm not 100% sure, but I suspect that's the case. Bucket features, we want to have 10 buckets for zip codes. Text features, that's basically the narrative for the consumer complaint. Okay. Someone's posted something on the chat. Okay, so Mayank was saying we will have to use tf.function decorators to apply the tf graph support for optimization really to zero memory and data conversion. For TFX pipelines handling needed from additional for TFX pipelines handling custom. Yeah, go ahead.
Yep. This is with respect to some other libraries or functions that we import, and we might need some complex argumentation or some like an argmix if we want to perform some sort of that transformations in the image pipelines. We might need to use function support for converting it to the TF graph for optimal uh, compilers with respect to the TF, the intermediate representations that we get. So that will be easy to transfer it and reuse it instead of trying to, how do I say it, completely make that library from scratch.
Yeah, and as you see, like this has nothing to do with, TensorFlow. But once you add that decorator, you are able to call it. So perhaps this is a way to convert some of the Python functions into TensorFlow. Am I right, Mayank?
Yep.
Okay. Yeah. So for some of the customization code, maybe, we can dig more into tf.function to make graphs out of your programs. Okay. Okay, so back to the code. For one-hot features, we want to try to use the tft.compute and apply vocabulary. And the book talked about this function. Basically, it's one of the amazing TFT functions. It computes all unique values of a feature column and then maps the most frequent values to an index. Then this index mapping is then used to convert the feature to a numerical representation. This function generates all assets for your graph behind the scenes. You can configure your most frequent in two ways, either by defining the n highest ranked unique items with top k or by using frequency thresholds above each element for consideration in the vocabulary. And basically then, once you have that, you pass that into the convert num to one hot function that we defined on top right here. And then you have one hot encoded features. So that's processed right here. Then if for the bucket features, you convert the zip code and bucketize them using tft.bucketize. And we have the filling missing function right here that we defined here, okay? And again, we only want dense tensors, not sparse tensors, okay? And for text features, we're not really processing it besides just filling the missing and also converting sparse tensors to dense tensors. Okay, then you have the outputs pretty much. Also, you want to transform the names. That's what it is. You have the transformation of the names with feature names right here. So, okay. Best practices. Feature names matter. The naming of the output features is important. And the book reuses the name of the input features and append XF. And you will see TFX official tutorial doing the same thing. So this might be a standard practice within TFX pipeline, just underscore XF. And the names of the input nodes need to match the names of the output features from the preprocessing FM function. Consider the data types. So TFT limits the data types of the output features. It exports all preprocessed features as either tf.string, tf.float32, tf.integer 64 values. This is important in case your model can consume these data types. So some models from TF hub, such as BERT models, require tf.integer 32. You can void that by casting inputs to the correct data types inside your models. Or so basically after you do the TFT, right? So before you feed them into the model, but after your TFT transformation. Or if we convert the data types in the estimator input functions. Preprocessing happens in batches. So we talked about that. This is why it mentions basically all the transformation steps need to be TensorFlow operations so that TFT can perform the operations in batches. Remember, no eager execution. Eager execution basically just means you want to execute it now. And TensorFlow 1, if you recall what we learned from Hands-on ML, TensorFlow 1 was pretty much no eager execution at all, mostly just graph. And TensorFlow 2 in 2019, I believe, they added eager execution into the TensorFlow 2 ecosystem, and things are much easier to understand for people to play around. But again, in TFX context, or at least TFT, there's no eager execution because the function inside of that preprocessing FN function need to be represented by TensorFlow ops. So if you want to lower an input string, you couldn't use lower. Okay, you have to use TensorFlow operation tf.strings.lower to perform the same procedure in a graph mode. So eager execution isn't supported. All operations rely on pure TensorFlow graph operations. So no eager execution. TF function can be used, but with restrictions. Okay, and Mayank mentioned the tf.function, and we took a look at it. So it seems like it can be used, but with restrictions. You can only use a TF function that accepts tensors. Okay, so lower wouldn't work since it doesn't work on a tensor. Okay, so we can't really trick TensorFlow in this case, by using some of the Python native functions in this case, because it doesn't, some of them don't work on tensors, or TensorFlow's definition of tensors. Okay, and PyTorch has a different definition. Obviously. So you can call a TFT analyzer or a mapper that relies on the analyzer, such as tft.scale to z-score. And it lists basically a bunch of TFT functions. You guys read through this, so I'm not going to go through it again. And those are pretty straightforward stuff. And if you're into NLP, there's some TFT functions for NLP tasks, n-grams, bag of words, TF-IDF, some of the feature engineering steps. And if you're into image, there are there's tf.images, tf.io APIs. tf.io provides useful functions to open images as a part of model graph. So everything has to be TF operations. So in this case, we're decoding the JPEG image format with decode function, decode JPEG function from tf.io, convert the loaded RGB image to grayscale, and resizing the image to 300 to 300 pixels, then convert the image to grayscale. So if you're into TF image tasks, dig into tf.image. If you're into NLP, I would dig into these TFT functions, and also mention TensorFlow text. So maybe TensorFlow text can also be used here. Okay, this talks about Apache Beam and standalone execution of TFT. I don't think we need to dig into much of that. And I want to spend the rest of the time talking about the pipeline itself, because we've been talking about different components. And I want to show you guys right now where we are, right? So in terms of the entire pipeline. So this is some of the code I took from the book's repository. And there's a file called base_pipeline.py. And this has the entire pipeline in components. Okay. And I just basically took some of the components that we've already seen and learned. And this is the pipeline_airflow.py. This is where you call the pipeline and orchestrate it with Airflow. Okay, and again, these all come from the books repository. I'm just organizing it to make it look better or easier to understand. These files exist within, so the pipeline underscore airflow.py is within the pipelines folder underneath the books repository. And the again, module.py comes from the components folder. And the other one, yes. So the other one, base pipeline, also comes from the pipeline folder as well. Okay, so let me, yes. And the Kubeflow pipelines is also here. Apache Beam is here. Apache Airflow is here. And we have a base pipeline that contains all the components. Okay, so obviously we're not done yet, but we have several components already. We have the example. Yeah.
Can I interrupt you just a quick bit? Can you
Sure.
to at least the base pipeline where the pre-processing step is being done, and on maybe the Apache Beam pipeline, just so we can see a comparison?
Yeah, I didn't dig into the Apache Beam pipeline, but that is not where it's happening. The pre-processing step happens right here. So we talked about example gen, right? CSV example gen, that's where it ingests the data. We talked about statistic gen, schema gen, example validator. That's where data validation comes in. You know, we generated a bunch of graphs, fancy graphs, distribution statistics about our data. We validated or generated a schema for our data sets. You know, if the features columns even present, or, you know, what's the, you know, are you requiring at least one category among the categorical columns? And do you have anomalies from, you know, your data sets, so on and so forth. We talked about that in the last chapter, and this was the second chapter, right? So now it's this, okay? And this is where module file comes in. And all these steps, all that pre-processing FN goes into the module file. And the way how you pass in module file, I mean, I changed it a little bit. I just defined that in the config py, which is much clearer. I basically just say, hey, module file path is equal to practice example director path and module.py. And if you look into the module.py, that's where the pre-processing FN lies. Okay, and all you have to do is actually just passing the module.py. It will be able to detect the function name, but you have to name it pre-processing FN. Okay, you can't change this name, but you can customize all the codes in all the other functions on top of that or below that, wherever you want to put it. Okay, but it has to contain this, because the transformer, the transform component needs to be able to detect that function in that. And module file is, again, is a parameter that's defined here, and I just pass it in as a file path. That's all it is. Then basically you compile all the components in a list, you return it, and then you pass into a variable when you call it, and pass that into the init pipeline function. basically init pipeline function would have all the components right here in the first argument, and you define your pipeline root. That's your directory for storing your pipeline. And number of workers, I believe that probably has to do with, you know, the processing or how you want to distribute your pipeline. And then you just call it init pipeline, call this function. Okay, and the full pipeline is obviously doesn't stop at transform, right? Because I just basically took the components that we've already gone through in the past chapters, but the full pipeline would go through, you know, all the way to transform, obviously, and then training quarks. Okay, bunch of training arguments or parameters, and that's, you know, next chapter. And you pass into the trainer component, and you have a model resolver, evaluator, evaluated component. Then you have a push component right here. You have a bunch of arguments that you could pass into the pusher. Then everything is completed. Okay, so the entire pipeline has these many components return as a list of components. And the way how Airflow calls this is that we talked about the init pipeline function. That's where I took it from, pipeline airflow.py. And we have the init components function right here. And you initialize the pipeline right here. And you pass in the pipeline into a function called airflow dag runner. And you have the config, airflow config file or parameter right here and passed into airflow pipeline config. And you .run this pipeline. So that's how you pass into Airflow in order to run this entire TFX pipeline. Is that clear, Mesh? Okay, any questions on this? Everything is pretty straightforward. Trust me, it did not seem straightforward to me from the book and the way how this repository is, not this one, but this one is organized. It's everywhere. But I, you know, since we have to do this book, so I just had to kind of just organize it so that we all can understand what's going on. Pretty much. Okay, yeah. Again, I think the books repository should have been organized a little better because some of the notebooks, you know, there's some notebooks lying in a folder and some of the .py files lying in another folder. Then you have a pipeline folder right here, and and you have a components folder. So yeah, it was not very straightforward for me to understand initially. But right now, now I have a better understanding of this. And again, I think config.py is just something that's pretty handy. You know, you can define all the directories in one file, and out of every other file, you can just call config.py to for the path. Okay, so it's already 11:33. I wanted to go over this, but seems like we don't have time. It is TensorFlow's own tutorial on the TFX transform components, but also again, what I like about this is it has entire pipeline defined right here. Not here, but right here. It's similar. And again, we're passing in module file into the transform component, and also goes through trainer and pusher. But learn how, like, what I would say is the valuable lesson is where how we define the pre-processing FN. Okay, and you know, because for every data set, for every project, that pre-processing FN is different, you know, and you would have to learn how you can process the data using different TF functions and all that stuff. So that's where you're going to spend most of the time to clean up your data. And every logic has to flow into this pre-processing FN. Okay. And so let me post this in the chat, just so you guys have it. And you can go through it if you have time. If we have time next week, I might just spend the first 15-20 minutes going through this, because we don't have reading for the next time. We just have Scikit-Learn workshop. I believe that's what's on the schedule, right, Mash? Is that what it is?
I'm sorry, I missed what you asked.
Our next session is Scikit-Learn pipeline, right?
Right, that's what we have.
Yeah.
Hands-on practical.
Yeah, so I guess we're gonna go through this then next week because we do have time. And then we're gonna go through Scikit-Learn pipeline. The reason why we included that is because right now we've pretty much went through all the steps of data ingestion, validating your data sets, and transforming your data sets into a model-ready format. And we want to kind of just parallelly talk about what Scikit-Learn offers in terms of doing the same things. But obviously it's not as good as TFX, but there is something that's called Scikit-Learn pipeline. So, and you can write all your customized codes to flow into a Scikit-Learn pipeline. And that's what people typically do, yeah.
Before we close, would the value of Scikit-Learn pipeline as opposed to TFX, with Scikit-Learn being more of a standard package that runs on any framework and cloud environment and so on, would that make Scikit-Learn a lot more extensible and flexible for building a pipeline? You're basically working with something at a more basic level versus something that is like TensorFlow extended is very specific to just TensorFlow.
Yeah, I would say so. So I would imagine like Scikit-Learn pipeline would be able to help you on many of the traditional machine learning tasks, and perhaps OpenCV as well. But obviously, Scikit-Learn is not on deep learning. But I would, I would definitely look into Scikit-Learn pipeline, because Scikit-Learn pipeline is more like just a function. And let's look at the source codes a little bit. It's just, it basically just assembles all these steps for you. It doesn't have all this fancy like metadata store, things like that. It basically just, it's a bunch of steps that ties everything together for you. And let me give a quick example of what Scikit-Learn pipeline looks like.
Okay, for next week, how would this discussion would go about? Would you follow a book or a particular?
No, we won't follow a book. Yes, that's a great question. So what we'll be talking about is, let me go through, let me share my screen. It's GitHub called deploying machine learning models. So let me share this GitHub on chat. So this is something that we'll be going through, and this is a great way for me to share what Scikit-Learn pipeline looks like. This is actually a course on Udemy. So if you want to spend $20 on this, you know, with new accounts, I think that's definitely worthwhile. But obviously, everyone, you know, has a different situation. But I think it's totally worthwhile to get that course, and I've learned a lot. And let me show you what a Scikit-Learn pipeline looks like. This is a regression model processing pipeline. Yes. So this is what Scikit-Learn pipeline looks like. And you basically just from Scikit-Learn pipeline, import pipeline. And you define all the pre-processing steps elsewhere, but you pass it into here, you know, or, you know, you probably can kind of compare this into this, right? This is similar. And that's why we want to do this next week. Categorical imputer, numerical imputer, temporal variable, rare label encoder, categorical encoder, log, transformer, drop, features, min, max, scalar, and then you have a linear model or so in the end. And what's very helpful is that you can switch or replace, you know, a model just like one line right here. So it becomes way much less error prone, and it's much clearer, right? And everything flows through nicely. So, and if you want to take out one, you know, pre-process step, you can just do that by just deleting this. So everything is modularized, and this is where you define, let me show you processing codes, preprocessors. So this is how you customize Scikit-Learn pre-processing steps. You always do that in a fit transform. We saw that a little bit from hands-on ML, but we're gonna do it really hardcore with this GitHub, basically. You know, you have a categorical imputer, numerical imputer, temporal variables estimator, and all that stuff. This is where you do all the pre-processing steps, and every one of these classes flows into your pipeline.py, and you call this pipeline. Okay, that's it. I know we've run across past time, 11:30. It's already 11:42. But any questions before we go?
I would like to give since Scikit is traditional and would only work on CPUs. So if I have to accelerate it with some respect to a dual purpose, suppose, because in the industrial settings, I don't think so. Scikit-Learn will be much of a help, but from a research perspective, are trying to deploy some small functions on a tabular data, for example, that might be helpful. So I just wanted to compare because even TensorFlow Extended have all this plus more with respect to the extensibility and the other aspects that we talked about.
I think you kind of have to separate different components. Well, let me use another word because we've been talking about components. Separate different like steps out. I don't think you will have problem in terms of inference. Okay, traditional machine learning models would actually be faster in terms of inference and inference speed. So, and once you deploy your models on the cloud, And the AI model we've talked about on GCP, Google Cloud Computing, would auto scale your model with more containers. Pretty much that's just what it is. And I'm sure SageMaker does the same thing. Now, in terms of training and pre-processing, you have, well, at least in terms of pre-processing, you have Apache Spark, okay, and you have other libraries that help you to process the data in a parallel way. So you're not using Scikit-Learn in that step, right? Now, in terms of training, I don't know how fast Scikit-Learn is compared to other libraries that perhaps can help you to train faster. I don't know.
If I give an example of rapids, for example, the
Yeah.
traditional scikit-learn functions and methods and the components and the steps that we talked about are being ported to rapids and are processed in a much faster way on the GPUs. So I was thinking maybe we can of course this is the basic, the classic that we need to get a full hands-on uh, uh, implementation, and it needs to go into our head. Then we can try some of the other stuff that increases the performance and which are actually useful in the industrial settings. So I was thinking maybe
Yeah.
that.
Yeah, I think scikit-learn is used in industrial settings. Again, I think you maybe the training process, and again, I think the training process is not done in a it's done elsewhere anyway, right? The industrial requirement is more on the production inference speed and the production and the data processing layer. So, and these two are not necessarily an issue like what I was saying. Basically, for model inference, scikit-learn models, traditional machine learning models are actually faster. That's what I've learned, and you can scale them, parallelly with more containers, and with data processing, just use Spark, so I think Terrence mentioned, Winshan, how do you set the Python in? Yes. So I basically just, let me share my screen. I think I was looking at your comments, or basically your post in terms of setting up the environment. What I think this is your Ubuntu environment. Yes.
So, I mean, this is working, and if I use Jupyter Notebooks, I can set the environment, but within Visual Studio, I notice at the bottom of your screen, I see your environment set, and I have no idea how to. I'm kind of new to the Visual Studio.
Yeah.
So you see at the bottom where you have Python 384, and then you have your Vin, your environment set at the bottom of the screen there.
Yeah, exactly. I guess, let me just close off this. So for whoever wants to listen to this, you can stay. If you want to go, feel free to go. Yeah, thanks everyone. I'll, just talk a little bit about Visual Studio Code, since Terrence has a question on this. So this is basically, this has something to do with your, how the Visual Studio, the kernel within Visual Studio code executes your Python code.
Okay.
And usually when you have a Vim folder right here, which I do right here,
Okay.
right? It will automatically, when you open up the folder, it will automatically try to detect your kernel, your virtual environment kernel
Okay.
within the Vim folder. And that's what it is. Okay.
I see.
Yes. But it sometimes it might not be accurate. And it could happen. The way you want to check is you want to check this. So which Python. So now I know, okay, so this is within the consumer complaint venv.
And I don't have a Vim. I basically created, a couple of project folders, and then within those, I have my environments set. So when I was running code today, I'm like, well, how would it know? Because each one doesn't necessarily have the same packages installed. So I'm like, okay, I don't know how it's going to know which one to use because, like you said, I don't have a default one. So
Yes. So what you want to always check is which Python.
got you.
Yeah, and you will know. Now note that this terminal is in a different environment than this one. So sometimes these two do not match, and you want to
Okay.
make sure these two match. And this is this. Okay, this.
So when I moved into, I actually, from the terminal, I actually did what you just said. I moved in or I activated one, but it didn't reflect it at the bottom of the screen. But does that mean I'm in? So if I do it within the terminal, is that the environment that it's sourcing?
So what you want to do is, if let's say this one is run, what you want to do is enter interpreter path. So your terminal should be correct, right? At least because you have the control to the terminal.
Correct.
So what you want to do is enter into that, and then it should be correct yourself.
Let's see where you're getting that at.
So what you want to do is copy paste this path and click this enter interpreter path.
Oh, I see.
And
Gotcha.
enter that. Yeah. So then this interpreter matches your terminal environment.
I see.
Yeah.
So then I would pick the Python inside of the environment that I want to run out of.
Yes,
Okay,
exactly.
gotcha,
Exactly.
gotcha.
Yeah. And this obviously is your venv, right? So it should match your project venv, project folders venv folder.
Gotcha.
Yeah. And you will see when you activate that, you will see everything from pip show is from that exact same Vim folder.
Gotcha. Okay, perfect.
Yeah.
I get it now.
Yeah, exactly.
Yeah, because you've kind of turned me on to this, so I'm using it, trying to use it exclusively and just get completely away from the Jupyter notebooks as well.
Yeah, absolutely. This is the way to go, I think. And again, and more people are adopting this actually.
Well, I've sat in on
yeah.
a couple calls with Oracle because, they're doing a lot in this space as well. I know they're kind of an underdog, but they're making everything centric inside of the database, basically. So you basically source it, you run it, your APIs call procedures inside of the database, both Python as well. But what's funny is they use this as well. So almost every, I sit on multiple sessions and everybody's using the Visual Studio Code to do the work. So
yeah, exactly. Because the alternative is, now when do you use Visual Studio Code? When you develop a package, when you develop anything that's a little more complicated than a .py file, then that's pretty much a lot of things. Yes. Now, when it comes to server operations, you don't have this, right? A lot of times, for me to do some of the work, I need to spin up an EC2 or whatever it is. Then I'm on a server, right? So then I don't have Visual Studio Code. Then I just have to use Vim, and I'm not very good at Vim yet, and I try to be better. But this is again, free, right? And you have
Mhm.
a bunch of great options. You can even collaborate with people.
Yeah, it
So
is neat.
yeah, you can collaborate with people, like do pair programming, and people can edit your code and you can edit someone else's code with extensions like this,
Mhm.
right? So, and you have Docker extensions. It's very cool. You can probe into the Docker container from that extension, all kinds of great stuff. And it's not language specific. It's every language, and it's free. PyCharm is not free, right? It's $10 a month, something like that. And if PyCharm is a little too heavy sometimes, has a lot of other stuff. But Visual Studio Code is just great. Yeah.
Cool.
Any other questions? I've seen what you had here. Yes. So a lot of times, I do have this setup.py because, a lot of times I am developing, even if it's a pipeline, I develop a package anyway, because it's just easier. And it's easier for me to, Dockerize it once I have a package, and once I have the Docker, file composed, then I just ship that Docker container to, AWS ECS. It's just like easy. And in that Docker file, I just have pip install not pip install e, but pip install. That was it. And um, and we'll just install it setup.py instead of doing pip install -r requirements.txt. So which is what you have here. Now, with this, I do understand that, but once you have the virtual environments, I don't know if it's 100% necessary. I don't know. I could be wrong. But once you have like Python, again, like which Python, you already know you're calling the environment, right? So if you're calling the Python 3 and it's the same thing. Python or Python 3, it's the same thing. You're always, I don't know which Python 3. Yeah, exactly. So Python 3 is also from the same virtual environment. So like whatever you do with Python or Python 3, it's always from that virtual environment as long as you have this activated. So again, there might be exceptions for this, but so far I've found, just pip is enough. So yeah.
Okay, got you.
Anything else?
No, that's perfect. That's what I wanted to know. Thank you very much for taking the time.
Yeah, no problem. All right. I think we should probably close now. Thank you everyone for staying so long. I really appreciate it again. And I think next session will be fun with Scikit-Learn. We'll be switching gigs a bit and looking at another framework that's very popular. So
Good job, Chang. Thank you.
Thanks.
thank you,
everyone.
Mesh. Thank you, everyone. All right. Have a good night.
Stay
Thanks,
safe,
everyone.
everybody. Stay safe, Mike. Bye.
Yep.
Thank you.
Bye.
Bye.
Yeah.
Bye, everyone.
Bye.